All right, we talked about area yesterday. Tell me some things that you remember from yesterday. Big ticket items you remember. Top minus bottom, big part of it. What else? Anything else you remember? Limits of integration you get by finding the intersection point sometime, a lot of time. What else?
Look where the area is bounded by.
Okay, you're going to look at all the bounds for the area. Tell me something about the area. It's always positive, always positive numbers, okay? So those are the things we talked about yesterday. So today we're going to extend that a little bit, which is going to really mess with some of your minds, okay? I'm just telling you that because it always seems to, all right? So let's look at this problem that I've got up here on the board, okay? Find the area between the graphs. I think the first thing we need to figure out is what area are we talking about? All right, we're going from -6 to 1 here, and we're talking about this region right here, this funny looking region. Would you agree with that? Okay, so we're integrating -6 to 1, but we need top minus bottom. What's top? The blue one, the red one, or the green one? Not the green one. Okay. Well, we're looking for just this region here. So what if we said the red is the top? It's going to get all the way up there, isn't it?
The blue one, it would be both of them to a certain point, correct?
Okay. Kinda. Yes. In order to do this, we're not going to integrate -6 to 1. What are we going to do? We're going to integrate from -6 to here. We're going to integrate from -6 to, what is that, -2.343, whatever that is. And what's the top function there? F, G, or H? From -6 to 2.34 here, is it F, G, or H? It's going to be G, isn't it? G is our blue line. This is the top. Okay, some of y'all were thinking red, right? Okay, when I say top, what's the top of the region that we're looking to find, okay? Because you're right, the red one is on top. The red one is the highest, but we aren't wanting to know the area all the way up to here. We're wanting to know just the area to this point right here. So G would be our top function. That's as high as the area goes. Then we're going to integrate from that -2.343 all the way over here to 1. And what's the highest that we want to go now? Now the highest we want to go is our F function. Would you agree with that? Okay. Now, that will work. There's nothing wrong with that. That's right. Yeah, good question. What about the bottom? Well, technically, yes, we've got to subtract the bottom, don't we? But the bottom is 0, so subtracting 0 is not going to really change it any. But it's good to get in the habit of top minus bottom there, okay? All right, now I have an obvious question for you. What if I take this region that we've colored in the blue crisscross and turn it like this? Did I change the area of it? The area is the same, right? Okay, but in reality, we're talking about physical areas, so the physical area is not going to change either way. But we didn't change anything. So if everybody turns their head to the right and looks at it, if you turn your head to the right and look at it, Can you see that this would be the top function now? And this would be the bottom function if we're looking at it sideways? And if this red is the top function and this blue is the bottom function, we've only got to integrate one time. That might make our life easier, mightn't it? Instead of two integrations, we're down to one integration. So there's another way to find this area. What we've done here will work. But if we could figure out this function, this red one, and this function, this blue one, when we turn our head sideways, we could integrate. Okay? Now let me back up a little bit. Y'all remember us talking about an accumulation function yesterday? At the very end, we talked about accumulation function, where you had to find f of 0, f of 2, f of 4. What was that all about? What does it mean to accumulate? We're just adding area. So if you think about it, with what we've got written here in black, we're adding up all of these little areas this way. Would you agree? And when we add them all up, then we've got the total area. Okay, now if we think of this, and I'm going to use a highlighter for this. No, that's not a highlighter, is it? That's a highlighter. If we think of this red one that I drew as the top and the blue one that I drew as the bottom, now we are adding, but we're adding this way. We're adding this way suddenly. Do you see what that might change about what we got to do? When we turn our head that way, when we turn our head to the right, now if we're wanting to add up all of these horizontal yellow pieces, we're no longer integrating with respect to x. We're now integrating with respect to y. Because when remember, the little black lines are integrating with respect to x. We're accumulating. We're adding them from the left side all the way to the right side. But the yellow highlights, we're adding upwards. We're adding the y values there. So now, if we're integrating with respect to y, what does that tell you suddenly? If we're integrating with respect to y, what does that change about what's in here? Yeah, everything we've got is x. Are those functions that we've got written over there going to be something we can put in here?
No.
How are we going to get something we can put in there?
Maybe change those to y equal.
That's right. If we think of both of these functions as equal to y and solve them for x, suddenly we'll have functions of y, okay? So for the g function, it's going to become, in working with the g function, it will become 0.5x plus 3 equals y. If we're solving for x, it becomes 0.5x equals y minus 3. And it becomes x equals y minus 3 divided by 0.5. What's the same as dividing by 0.5? Times 2. So it becomes y equals 2x plus 6. So that becomes one of our functions in terms of y. Now, which of the functions is 2y plus 6? Is the blue line and the black line 2y plus 6, or is this curved red one 2y plus 6? The black one. So this is the same as, think of this as our g function, okay? Let's do the same thing for our other function. We had the square root of negative x plus 1. So what's the first thing we need to do to solve that out? To get x by itself with that function there. Square both sides, so we get negative x plus 1 equals y squared. Negative x equals y squared minus 1, or x equals 1 minus y squared. So that's what our f function is in terms of y. So we've got two different functions now written in terms of y, so we can put them in here. Which one's the top function? Is the red function the top function, or the black and blue function the top function? The red function is. So we're going to put it in there that way. 1 minus y squared minus the other one, 2y plus 6 in parentheses. Good question, and I was afraid somebody was going to ask that. I'll answer that question in a minute, okay? I'm not going to get to it yet, but I'll answer it in just a second. So we've got our functions in here. What are our limits of integration? What are we integrating from and to? Again, it's got to be y numbers. It's got to be this yellow band starting down here at the axis. So what is y equal to down here at this point? What is y equal to? 0. How high up do we integrate until y equals what? 1.828. And with both of those integrals, if you integrate the green or you integrate the black, either way you should wind up getting the same answer. You should wind up with the same thing. Now, Mary is very astute, and she said, well, yes, the red's on top if I turn it to the right, but what if I turn my head to the left? Now the black one, the other one looks like it's on the top, right? I agree with you, okay? So the question becomes, how do you know to turn your head to the right? Okay, the only good answer I can give you for that is, if you integrate this with the black line on top and the red line on the bottom, you're going to get a negative answer. What do you know about a negative answer? Can't be right. Okay? In fact, if you were to integrate the black line, if you were to change this around and make it 2y plus 6 minus parentheses 1 minus y squared, you'd get the exact negative of what we're supposed to get there. So the best answer I can give you that I can make you understand is, you're always going to be turning to the right and thinking of this as a positive. Think of it this way also. In your quadrants, everything to the right is positive. Your x's and your y's are positive, right? X is positive going this way, y is positive going that way. So when we turn it, we want the positive stuff to stay on the top. If we were to take this and turn it that way, now we've got a negative x up in the air. Doesn't make as much sense. All right? Now, I can hear what's going through your head, okay? It's late in the afternoon, and I really don't want to hear all this, and I could have done it with the x's here, so why on earth do I need to know how to do this, okay? The answer is, sometimes it's going to be so much easier and almost impossible to do it in terms of x only. Sometimes you're going to have to use the y's to get that there, okay? Do you understand in concept what we just did? All we did is we took the functions that were given and we solved them for y, so we got them in terms of y instead of terms of x, and we integrated in terms of y. The biggest thing that students have the problem with here is, if I'm integrating with respect to y, then my limits of integration have to be y numbers that I get, and everything in here has to be in terms of y. I can't mix and match because the x's make it easier. All right, I'm not going to finish that off because I'm confident you're capable of doing that. Let's look at the next one. In fact, that is the next. That's what I just turned there, so I'm going to keep going. Find the area of the region bound by the graphs of x equals 3 minus y squared and x equals y plus 1. What's strange about what you see? Or what's different than normal there? Yes, they're already solved to be x equal. What does that make you think that that's probably going to be the case then? How do we integrate with respect to x or y, you think? Y, more than likely. So that's what we need to be thinking of. We're integrating with respect to y. Okay? How are we going to find our limits of integration? Set the two equal to each other. 3 minus y squared equals 1 plus y. Bring it over here, we get y squared plus y plus 1 minus 3 is minus 2 equals 0. Y plus 2, y minus 1, negative 2, and positive 1. Some of you good algebra students, did I do any of that right? If I put 1 in there, I get 2 in both of them. If I put negative 2 in there, I get negative 1. I think so. So our limits of integration are negative 2 to positive 1. Now the question is, which one's on top? Is 3 minus y squared, or is y plus 1 on top? Probably 3 minus y squared, okay? That would be my guess. What I would do, and if you want to draw a graph, that's great, but I would pick a number between here. What's the number between there? 0. If I put 0 in this one, what do I get? 3. If I put 0 in this one, what do I get? 1. Which one's on top? The highest one is, right? The 3 minus y squared. Minus the y plus 1. Now, how do you know that they don't cross somewhere in there? You remember we had some the other day that did some funky stuff, and this one's on top for a while, and then this other one was on top for a while? Those are the only intersection points. That's a very good case that it's not going to. What do you think I just told you. This first one looks like a parabola. How do I know it looks like a parabola? Y squared. So it looks like a parabola. This negative sign, what do you think the negative means about it? It would normally be down if it were x squared, right? What do you think if it's y squared? Why is it going to be opening this way or that way? Y squared with a negative in front of it should be opening to the left. So we ought to have something like that roughly with it, okay? And then if we do, we can plot points for this x equals y plus 1 relatively easy there, I think. 0 over 0, when x is 0. Oh, it's hard to think that way. When y is 0, x is 1. So that's here. And then we go up 1 and over 1. So it looks something like that. But you get some idea of what it looks like there. Okay? Confusing? A little hard to visualize the picture, I think. But the process, once you get here, it's easy. Because whether it's y's or x's, it doesn't really matter. As long as you know in your head that all of these things are talking about y. Your limits of integration and your functions are talking about y. Okay? Questions, comments, observations? All right, let's look at, this is the actual pictures of these. Now, having said that, look at these pictures. If you were going to integrate these with respect to x, what would you do? Here are our two functions. Or actually, we wind up with 3 functions. How would you do this problem on the right, integrating with respect to x? What's the top function? I'm going to number them here. This is the first function, this is the second function, this is the third function. What's the top function? Or is there one top function? Is there one upper bound to this region there? Looking at it straight on. I see you turning your heads. Yeah, when you turn your heads, it's easy to see. But straight up and down. I want to prove to you why you need to be able to do this with y's, is what I'm doing. If I'm looking at this straight on, and I'm going to integrate top minus bottom, well, this line is on top until I get to there, isn't it? So I've got to integrate from -1 to 1, the top, which is x minus 1, minus the bottom, which is negative square root of 3 minus x. And then from 1 on, this number 2 function is my top. So I'm going to, that's not 1, is it? I'm integrating to 2. I'm going to integrate from 2 to 3 with that function being my top one. And the 3 function is still the one on the bottom. So suddenly I've got two things to integrate. Do you think that's going to be harder to do? I've got to integrate. Well, first of all, I had to figure out what they were in terms of x. Then I had to be able to draw them and figure out my top and bottom. I think that's going to give you a lot more work to do. You'll get the same answer, but it's going to give you a lot more work. Do you notice that the integrands are nothing like what we had with the y's? The limits of integration are not even the same as what we had with the y's. We're going from -1 to 2 and 2 to 3. But that'll get you the same answer if you're happier with the x's all the time, okay? What we did will get us the same answers there. Just get it to us a lot easier. Or a lot quicker, I think. Hence, anytime you see problems like these 31 and 33 that I've got up here that are solved in terms of y, you're going to integrate with respect to y. Okay? So we're going to integrate these. We're going to find our limits of integration by setting them equal to each other, just like we did before. We'll walk through the same process as before. Any questions about that? Now, this is a cheat to it, okay? If I rename these f of x equals x squared and g of x equals x plus 2, what have I done to them? Graphically, I've moved it. Would you agree? Because f of y equals y squared is going to be open like that. This f of x right here is going to be opened like this. The x plus 2 is going to be a line here. The y plus 2 is going to be a line here. So we flipped it. Have we changed the area? So, if you want to change your variables from y's to x's, you're going to get the same answer. If x's make it easier for you, if they make you less likely to freak out, you're going to get the same answer by doing it that way. In the end, what you write to turn in, what you want that grader in May to look at, needs to have the y's back in there instead of the x's, because they're going to be sticklers for you integrated with respect to the right things there. But you're going to get the same answer there, okay? Questions, comments, observations? All dealing with the area, as long as you find the area through proper integration techniques, I don't care which way you attack it there, okay? Very good. That is all for the day.